Hi there, this is section 2.8, graphing linear and absolute value inequalities. So in this section, we're going to graph a linear inequality and we're going to graph an absolute value inequality. All right, so let's start with our vocabulary. What is a linear inequality? So it resembles a linear equation, but with an inequality symbol instead of an equal sign. For instance, our inequality would be y greater than negative 3x minus 2. So our linear equation is like a linear equation, that negative 3x minus 2. So the only difference between these two are the symbols. All right, it's that simple. Now let's talk about boundary. What is boundary? So let's look at a graph and let's graph y equals negative 3x minus 2 and y greater than 3x minus 2. Negative, sorry. Okay, so we're going to start with your y-intercept. Go at 1, 2, 3, and to the left 1. So it would be here. And let's look, so the difference, so you graph it just like you would an equation, except for you look at the inequality sign. If it's a greater than, less than, it's going to be dotted. I mean, greater than or less than. If it's a greater than equal to or less than equal to, then it's going to be a solid line. Okay, our inequality is greater than, so it's going to be, I didn't do a very good job here, but you get the point. All right, so now we have to shade. We're saying, when is y bigger? So that there's a couple ways to look at it. You go straight to the y-intercept right here and say the graph y gets bigger here, so that's going to be on this side of the line. And so that is what you would shade. And we can also say what is greater than. It's to the right. But it depends on what the slope is. So that's why it's easier to go look at the y-intercept. The other thing is we want to test a point. We always want to test the origin if possible. Sometimes it's so close and you don't want to chance it. So you want to use a point on the either y-axis or x-axis. Well, the origin clearly is not in here, so I'm going to put 0, 0 in here. It's got to make the inequality true. So does 0 greater than negative 3 times 0 minus 2. 0 greater than 0 minus 2 or negative 2. Is this a true statement? Yes, it is, so I shade it correctly. What if I was to pick, let's say 3, 4, let's say this coordinate. This is negative 4, comma 0. All right, that's clearly on this side of the line. What if I were to shade it this side instead? Well, I need to make sure it's true. So I'm going to put this coordinate in there. So 0 greater than negative 3 times negative 4 minus 2. 0 greater than 12 minus 2 is 0 greater than 10. That's a false statement. So if I shade it down here and picked a point in that region, it's wrong. Okay, let's look at example 1. Example 1 says graph x plus 4y greater than 2. Now, if you want to leave it in that form, that's fine, but then you have to make a table. You cannot graph this from here. So let's change this to x plus 4y equal 2. The only thing you have to be careful when doing this is if you multiply or divide by a negative, you must remember to flip this inequality sign. So minus x, I'm putting it in slope-intercept form. Divide by 4, divide by 4. Y is equal to negative x, 1/4 x plus 1/2. There is my equation. So now I'm just going to change this to say y greater than negative 1/4 x plus 1/2. How do I graph it? Well, I come to my graph just like this, and I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3. Oops. 3, 4, 5. So I'm going to go to 1/2, which is about right here. And then my slope is negative, so I'm going to go down 1 over 1, 2, 3, 1, 2, 3, 4. About right here. So when I connect the dots, well, I need to determine, is this going to be dotted or is it going to be a solid line? Well, my inequality is just greater than, so guess what? My line is going to be dotted. Of course, you're going to make a better line than this. Now, we said y is greater, so I'll go to the y-intercept, and y gets bigger up here, which is on this side of the graph. Again, I'm going to test point 0, 0, because I know this is 1/2, so clearly 0, 0 is not in the shaded region, so I should get a false statement. Okay? So 0 plus 4 times 0 is greater than 2. So this is 0 greater than 2. No, it's false. And that is below the line, and I didn't shade there, so I need to we know that the solution is above the line, so I did shade correctly. So you have to put it in slope-intercept form. You graph it as if it was an equation instead of an inequality sign. Determine whether it's a dotted or solid line, and then determine where you shade. If you go to the y-intercept and it says y is greater, you're going to shade on up here, so whatever side of the line is. If it's less than, you're going to shade down here, which would be, in this case, if it was less than, the solution would be down here. And you're going to test a point. It could be any point that's in this shaded region or this shaded region. It does not matter. Now, we call this line the equation of the line, the boundary. Okay? So this is this equation here, not the inequality. So it would be this with an equal sign. This equation is the boundary of the region. Okay, so pauses do guided practice 1A and 1B. Let's look at example 2, the real world example. And it says, a recreation center offers various 30-minute and 60-minute art classes. The recreation director has allotted up to 20 hours per week for an art class. Write an inequality to represent the number of classes that can be offered per week and then graph it. So they tell us, whoopsie. Oh, what's going on here? So they tell us that we have 30-minute classes. So I'm going to let X equal 30-minute classes. And I'm going to let Y equal the 60-minute classes. Okay? So we're allotted up to 20 hours. Now, do you notice that these are minutes, but they give us an allotted time up to, so we have less than or equal to 20 hours. But I must convert this to minutes. You have to be in the same unit, so 60 minutes over 1 hour equals 1,200 minutes. So they want us to write an equality. So I know that X plus Y has to be less than or equal to 1,200. Whoops. Okay, so I have 30-minute classes, right? 30 minutes times X, and then a 60-minute class is going to be 60 minutes, right? So the number of minutes is going to be less than 1,200. So I'm going to simplify by dividing everything by 30. And I'm going to get X plus 2Y less than or equal to 40. And then I'm going to move the X over, so 2Y less than or equal to negative X plus 40. Divide everything by 2, so Y less than or equal to negative 1/2 X plus 20. So here is my inequality. And then to graph it, I'm going to make a graph. I'm going to go 5, 10, 15, 20, 25, 30. I'm going to make these 10, 20, 30, 40, 50, 60. So 5, 10, 15, 20. Okay, and then I'm going to, instead of trying to figure this out in graph, because these are by 5s and these are by 10s, I'm going to find the y, the x-intercept. So I'm going to put 0 in for y, and it doesn't matter which equation, I can put it in here. So if I make this x plus 2y equal 40, I put 0, this cancels, so x equal 40. So 10, 20, 30, 40. All right, and it's a solid line. So there's my graph. And then it's going to be less than, so I'll go to the y-intercept, y gets smaller here. So this is where I'm going to shade. All right, so I know it's not going to go all the way because we're talking about quantity and it doesn't go past the quadrant 1 when we're talking about quantity. Can't have negative amount of time. So part B asks us to say, can the recreation director schedule 25 of the 30-minute classes and 15 of the, so they want to do 20, 15. If I look at my graph at 20, 5, 10, 15, it's right here. It's outside of the region, so the answer would be no, because it's outside of the region. So the director cannot schedule 25 30-minute classes and 15 60-minute classes. Now, how can I check this? I can put this as x, y into my inequality, and I should get a true statement. Or because it looks like it's outside, if I'm not sure, I put it in here, and because I know the answer is outside, you should get a false statement. But if you got a true statement, then your graph is just off. It's just because the numbers, and it would be true. Then she could. So you have to look to see, is it inside the region or outside the region? Pause the video and do guided practice 2. Let's do the last one. Graph the inequality at the absolute value of y greater than or equal to absolute value of x minus 4. So here we would just make a table because we haven't learned the transformations yet. We've learned the transformations, so we know that's 1, 2, 3, 4 is here. And it's going to be a solid line this way. And where am I going to shade? So we go to the y-intercept. This is y greater. So we should be shaded in here, inside the v, all the way up to infinity. And how can I check it? Well, clearly the origin's not in there, so I should get a true statement. Does 0 greater than or equal to the absolute 0 minus 4? What's 0 greater than or equal to 0 minus 4? 0 greater than or equal to negative 4. Yes, that's a true statement, so I've shaded it in the correct place. Pause, stop the video, and do guided practice 3A, 3B. I'll see you in class.